neutral, same number of protons, same number of electrons. What can change fairly easily is the number of electrons. So I wrote down here, ions want to have a full outer shell, and they will lose or steal electrons to get it. Okay? You might want your pink periodic table in front of you so you can kind of follow along. In fact, you do want your pink periodic table. Or if you want to, your textbook has a periodic table on page something or other. If you want one in color, your textbook has one on page 172. So either 172 or the pink sheet that I gave you, either one is fine. But you want one at least at your table that you can glance at. So ions want to have a full outer shell. We said that, you learned last year, that electrons gather in shells. On the innermost shell, there are 2 electrons. There's room for 2. On the next shell, there's room for 8. On the next shell, there's room for 8. On the next shell, there's room for 18. You don't really have to memorize that. If you look at your periodic table, in the first row, how many elements are there? In the very top row, how many elements are there? 2. How many electrons does the first shell hold? 2. In the second row, counting all the way across, how many elements are there? 1, 2, 3, 4, 5, 6, 7, 8. How many electrons does it hold? 8. In the third shell, in the third row, go across 8, it holds 8. In the fourth row, it holds 18, and we're not going to get much past there because to try and draw 18 or more electrons just gets yucky and weird. And like I've said before, the rules, Maleva, start to break down. Basically, the rules that we're teaching you work for the simpler elements, but when you get more and more shells, they actually start to overlap and intertwine with each other, and it's not as simple as just always moving out further and further and further. So we're going to avoid that. The number in the upper right corner of the elements square on a periodic table tells you the charges. Let me open my periodic table. I'll bring it back in a sec. Well, here, you guys want that. Okay. The number in the upper right corner of an element square on the periodic table tells you the charges. If it's positive, it tells you how many electrons it will lose. If it's negative, it tells you how many electrons it will gain. And if there's more than one number, that's telling you that there's more than one way for it to gain or lose those electrons. Like I said, we give you the simple rules, but it's more complicated than we're letting on, Hannah. So, if it's negative, then it gains electrons. And that's for the non-metals. That's the ones to the right of the staircase. Got it okay? Okay, you found where we are? Excellent. If it's positive, then it loses electrons, and that's for the metals. Okay? The metals are very willing to move and pass along electrons, which is why we use metals in wires for conductivity, because all electricity is moving electrons through long, thin tubes called wires. So we talk about Bohr diagrams. You learned these last year. We are going to do Bohr diagrams for a couple of days, and then we are going to punt them away because there's a much better, much cleaner, much easier, much less work diagram that I'm going to teach you this year. You do need to know how to do a Bohr diagram or how to read one for the provincial. So I'm going to cover it, but then I'm going to run away from it because they are a pain to draw. I almost hate teaching them in Science 9 because I know that there's such a cleaner, better way to draw them. But a Bohr diagram, it shows the organization of the electrons. It shows how many are in each shell for a particular element. Remember, each row in your periodic table represents one shell or one energy level. And you always have to fill each shell before you go on to the next one. So in the first row, never put only one electron. If you're planning on moving on, you have to put 2 before you can fill it up and move to the next row. Hopefully this is kind of coming back to you. How many of you did chemistry at the beginning of Science 9 last year? How many of you remember? Yeah, okay. So it's been a whole year, so I'm gonna, we're brushing the cobwebs off. Again, if you're finding this tough or confusing, you're normal. So, hydrogen and helium, they have only electrons in the first energy level. You want to give that pink periodic table that I gave you the other day? You might want that in front of you. Or you can open your text to page 172, and that's got a color periodic table. But it's worth, by the way, what I'm really trying to do in this unit, Taylor, is if I can get your eyes trained to look in the right place, on the provincial, I'm hoping that'll save you 10 minutes of searching when we add it all up. And on a 2-hour exam, if I can save you 10 minutes, I'll take that to the bank. So you're going to hear me constantly say, get out that periodic table. I'm hoping we can actually train your eyes that when I say nitrogen, your brain doesn't remember where nitrogen is. Your eyes just automatically glance in the right place. If we can get there, Jordan, that's a good thing. Time savers, okay? Lithium, beryllium, boron, carbon, etc. First shell is full, 1, 2. They have electrons in the second shell, the second level. And as you move right across the table, you just add one more electron. So lithium has 1 electron in its outer shell. Beryllium has 2 electrons. Boron has 3, etc., etc., etc. Sodium, magnesium, aluminum, etc. First and second shells are full. Now you've got electrons in the third shell. And then the fourth shell holds 18. We'll occasionally look at some of the more common elements in the fourth shell. We really won't go much past that fourth shell. In fact, as you go further, you can see right around element 57, that's where we have to actually break it up, because that shell holds like, I can't even remember, a bunch. Too many to try and even draw with dots, so we're not going to try. Noble gases are in the right-hand column. They have a full outer shell. And what this means is, since they have a full shell, they don't need to gain or lose any electrons. They are non-reactive, the fancy word inert. And I think I told you the other day, we used to think they were totally non-reactive, and in the 1950s, I think it was, a prof at UBC managed to get one of those to react with something. So he rewrote the chemistry books. I think now we don't turn the page, go across. I wrote down here the 2-8-8-18 rule. What do you think this means? How many electrons? And in fact, because we don't go much past that 18, you guys can add this with little arrows. Come on, pen. If you draw a little arrow to the 2 8s, we call those stable octets. Oct, like octagon, 8. What we say is when you're in that row, the elements want to get stable octets. They want to have full rows of full shells of 8 electrons. So if you see me, or if you see that phrase, or you hear me use that phrase, you know you're in row 2 or 3, and you know you're trying to fill up with 8. You want a stable octet. So, first period, 2 elements, therefore only room for 2 electrons. I'm going to repeat myself because this is so important. If this seems obvious and boring, then I'm doing my job, then you're learning it. Second and third period, 8 elements, therefore room for 8 electrons in each shell. Fourth and fifth, 18 elements, therefore room for 18 electrons. And that's why it's 2, 8, 8, 18. But really it's 2, 8, 8, 18 yuckiness, because then some of the rules that I've told you start breaking down. Key idea, when you're doing the stable octets, the first 4 electrons you draw by themselves, and then you pair the next ones up with another electron. In other words, you're not going to do 8 electrons all spread out like a stop sign. It's going to be 4 electrons like north, south, east, west, and then you start pairing them up. Why does that happen? Because the electrons have spin and the anti-spin mixes up with it, and it's a quantum physics thing. Trust me, it's the way it seems to work. Okay? So I think we're going to practice drawing some of these. So as part of your homework today, you will be asked to draw some board diagrams. Maybe not today. I might not get to it until when I see you guys on Friday. Oh, reminder, Friday is going to be your safety quiz. Okay? You writing this down, kiddo? Trent? Yeah. You writing this down? Yeah? Okay. So every time I see you, I'll check later. Friday, quiz on safety. What's the quiz on safety? I gave you the safety handout a couple of days ago. It's going to be questions like that. You'll find it pretty straightforward. You know, things like don't swallow something that's radioactive. I don't want to install that. So beryllium. What's the atomic number of beryllium? I don't have this memorized. I know it's in the second row. Atomic number 4. That's the same as the answer to how many protons. What's the atomic number? How many protons? How many electrons? 4 and 4. How do I figure out how many neutrons? Okay. So let's write this down, or did I include it at the bottom here? Oh, I did. The number of neutrons is the atomic mass, rounded off, minus the number of protons. Yep. That's for ions. This is an atom. Now, if I have, don't write this down. If you see the magic word ion next to it, then your alarm bell should go off, because then it just became trickier and you have to be much more careful. Great question. In your homework, you don't need to show this work, but these are our notes. Let's show this step. How do I figure out how many neutrons? So I'll go N for neutron. Oh, come on, I changed colors. I'll go N for neutrons equals, what's the atomic mass of beryllium? I don't have this memorized. 9? Or is that a German student saying no? No, 9 minus the number of protons. That tells you the number of neutrons. You can use a calculator, or you can probably do this one in your head. 9 take away 4 is 5. We'll show that step in our notes, Trent, in your homework. If you can do that in your head, I say great. Okay? Let's add that to the diagram. So we're going to say protons equals 4, neutrons equals 5. How many electrons? 4. How many can we draw on the first shell? So I'm going to go 1, 2, and then I move out. How many are left to draw on the next shell? I got 2 left. Put them on the points of the compass. You know what? I'm going to go here and here. You could put them top and bottom. You could put them one on the oh, hang on, I'm on the wrong row, Mr. Dueck. Nice job. I caught that mistake before you guys did. No candies. Here and here. There is a model of beryllium. A Bohr model, which we're going to leave in the dust in a few days because these are a pain to draw, but you have to know it. Let's try another one. Potassium. What's the symbol for potassium? Yep, right. Sorry? It's not a P, actually, so go hunting for it on your periodic table. I think it's in the left-hand row. K, right? Potassium is a K. Don't it? Well, long story. Anyways, what element number is it, Jared? 19. So number of protons, 19. Number of electrons, 19. I can't call that a no-brainer because you have to know that, but it's almost, when you see it, boom, boom, you got that answer right away. Atomic number, number of protons, number of electrons, Cassidy if it's not an ion. If it's an ion, then we got to muck around with the electrons. Neutrons, let's see. N equals... Jared, what's the mass of potassium? It's there somewhere. And can you round it off? It's usually right below the letter. Sorry? 39? So it's going to be 39, take away 19. Whatever's left is neutrons. In your head? 20? All right. Now let's draw it. So we would say, okay, 19 protons, 20 neutrons. How many electrons? 19. Okay. So is the first, well, what row is it in? Potassium, looking on the periodic table, how many rows down? Row 4, nice. So we're going to be filling in the first 3 rows. How many go on the innermost shell? The innermost shell is 2, so let's go 1, 2. Then we have the second shell, 8, and it would be 1, 2, 3, 4, and then they pair up. 5, 6, 7, 8. And the third shell is also going to be full. 1, 2, 3, 4, 5, 6, 7, 8. How many are going to be in the outermost shell? 1. How can you tell? Without actually having to, like, you notice, by the way, I haven't kept track of how many dots that I did. You can, but I know that anything in the first row is going to have 1 electron in its outer shell if it's a neutral atom. Anything in this, sorry, it's that first row, first column. Anything in the second column is going to have 2. So I just count over from the left on the final row. Where you want to put the final electron? How about at the top? Thunk. There's potassium. There's potassium. You can double check and count 19 electrons, but I'm pretty sure since we were careful, we got it. Now, let's answer Cassidy's question. What's the key word here that makes this question tougher? Riley. When I see the word ion, well, the little alarm bell should go off in your head. Ding, 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 ding. Got your attention, okay? The question just got tougher. Well, the first part is still the same. Riley, what's the atomic number? 19. How many protons? 19, okay? Protons don't change. Sorry, that's a lie. Protons don't change unless you're on the inside of a star or we're doing something with like a nuclear reactor. But for now, we're going to say protons don't change. How many electrons is the ion going to have? So looking at our previous picture, is it going to want to gain electrons? Is that going to be easier to get a full outer shell? Or is it going to be easier to lose electrons? Lose how many? How can you see that without the picture by looking at the periodic table? When you look at the square, what number do you see hiding up here? It's actually, I think it's not a number, it's just a symbol. What do you see? And what's in front of it? A little invisible 1. What that's saying is it's going to lose 1 electron. Okay, so instead of 19 electrons, how many? 18. How many neutrons? The neutrons is still going to be, what was the atomic mass, Jared? You said for potassium 39? 39 minus 19. So it still has 20 neutrons. Now, if you were really good at this last year, in your homework, you don't need to show all these steps, but I'm going systematically and I'm going organized because I know my students, a lot of them struggled, so I'm trying to give you a step-by-step method that you can look at your notes and say, here's what I do to get the right answer. Now, we draw. Heck, I'll go in red this time. 19 protons, 20 neutrons. First shell still has 2. Second shell still has 1, 2, 3, 4, 5, 6, 7, 8. Third shell still has 1, 2, 3, 4, 5, 6, 7, 8. How many are in the fourth shell? It's a trick question now, isn't it? How many are there if it was an atom? 1. How many are there now that it's an ion? None. None. Because that's the electron that it lost, that it gave away, that it sent to some other element. Now, the last thing that we did to show that it was an ion and not an atom, like what if you didn't have that word? What if all you had was the diagram? What you do is you put it in giant square brackets like this. And in the top right of the square brackets, you put the ion charge, like that. And I will be fussy. If you draw an ion and you don't add the square brackets, I will take a half mark off. Kind of coming back to you, I hope, maybe, sort of, vaguely. Bohr diagrams. I'm not a big fan of them. I recognize they have their use. Okay? As part of your homework later on, but you can make a little note, I'm going to ask you to do on page 176 Bohr diagrams for number 2A and number 2B. And you're going to hand that in next class or the class after. Make sure you put a title. How about practice problems, page 176? Make sure your name is on it. If you just hand in a piece of paper with some scrawls, I won't accept it. It's got to have a title and it's got to have your name. Okay? Let's keep going, though, because I want to show you the much, 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 much nicer diagram. Lewis diagrams. They're very similar to Bohr diagrams, except all we're going to show is the valence shell, the outer shell, which means way less writing. So we just finished potassium. How many electrons did potassium, the atom, not the ion, how many electrons did the potassium atom have in its outer shell? 1. Here is the Lewis diagram. You write the symbol and you put a dot for 1 electron. That there, without the circle, is a Lewis diagram. Which one looks like it's less work? Bohr diagrams or Lewis diagrams? Which ones are easier to do? Lewis diagrams. Now, why are they so handy? Well, when it comes right down to it, in most chemical reactions, all the action's going on the outer shell anyway, so what do we care about the inner shells? We use them in Science 9, Tim, because it's important that you do understand that there are shells, that there is stuff there, but we're going to kind of say, Maleva, you know what? Now in Science 10, we're more interested in the outside. Okay? So count over from the left to see how many electrons will be in the outer shell. And then you put that many electrons around the element symbol, still arranged in pairs. For example, I'm going to pick one. We're going to do a Lewis diagram for element V. You need to find the V on your periodic table. Vanadium, I think it's vanadium. Count over from the left. How many electrons are there in the outer shell? Count. Dung, dung, dung. So look at your periodic table. Start on the left-hand side. How many spots over do you have to go to get to vanadium? 1, 2, 3, 4, 5. I'm done. That's way nicer. And that also allows us to go a little further on down the periodic table without having to do bigger and huger concentric circles. Let's try one. So I wrote here, draw a Lewis diagram for a scandium atom and for a scandium ion. Okay. First thing that you do is you draw the symbol for scandium. You've got to go hunting and find scandium on your periodic table. And what's its symbol? I think it's SC, but double check because they're not always that obvious. Yeah? Capital S, lowercase c, capital S, lowercase c. The atom, count over from the left. How many electrons are there in its outer shell? Sorry? 1, 2, 3. Good enough. I know what you're talking about now, Tim. I know you're talking about a scandium atom with 3 electrons in its outer shell. Now, what about a scandium ion? Now, you ready? Well, the alarm bell should go off right now. Ion, things get tougher, things get more challenging. I need to think about whether it gains or loses electrons. Look at scandium. What's the charge? What's its valence charge on the periodic table in the top right corner? What does it say? 3 plus? So it's going to lose 3 electrons, which means how many will it have in its outer shell? None. So we're not going to draw any dots. But to show that it's an ion, we're going to bring those square brackets and put a little 3 plus. And that way whoever's marking this knows I didn't forget to draw the electrons. It's actually an ion. It doesn't have an outer shell of electrons. And I'll say it again because it bears repeating, Amanda. These are way nicer. Let's try a couple more. Draw a Lewis diagram for a sulfur atom and a sulfur ion. Step 1, find the symbol for sulfur. Is just an S? S for sulfur, S for Superman. Let's do the atom on the left-hand side. How many electrons are there going to be in its valence shell? And again, if you forget, just count all the way across. 16? I don't think so. Don't count the gaps. Right? In row 3, that white space means don't count that. So it's 1, 2, skip. 3, 4, 5, it's 6, yes? So remember, I'm going to go like this. 1, 2, 3, 4, and now we pair. 5, 6. Way nicer. Is that okay, Brandon? Thumbs up. Now, the ion. Does sulfur lose 6 electrons or does it gain electrons? Look at its charge. What does it say? Okay, so its outer shell doesn't vanish. Its outer shell gets completely full. How many will there be in its outer shell then? 8. 1, 2, 3, 4, 5, 6, 7, 8, and then to show that it's an ion, square brackets, and I put the valence charge, which is, I think, 2 minus, right? I can't say that it's easy peasy, but it's sure less work than the Bohr diagrams. Still got to know your stuff, Rick. Still got to know what you're doing. But I think there's less room to make sloppy mistakes. Yep. No. The number of electrons in the outer shell is 8, but there's also more in the inner shell, which we didn't bother drawing, and the inner shell, which we didn't bother drawing. Okay? Is that all right? So all we're interested in a Lewis diagram is just drawing the outer ring. Yeah. That's the disadvantage with these, but we're arguing, you know what? If you're drawing that, you probably have a periodic table, and you know how many electrons there are on the previous shells anyways, because you got it sitting there. Is that all right, Cassidy? Awesome. We are going to pause here. Have some practice for you. Lots of practice. Take a look at this, please. Let me walk you through it. And then I'm going to turn you loose. There's a total of about 25 questions. I'm going to be giving you about almost 25 minutes, so it's about 60 seconds a question. If you hustle, you can probably get this done in class, okay? I will put an answer key online because I didn't attach the answers, and I will go over the answers with you next class. Also, next class is your safety quiz. But here's what you're doing. So the instructions say, for the first page, you're going to be doing kind of like mini periodic table squares. It says, step 1, complete the squares by adding the atomic number, the name, and the atomic mass. So you're going to put the atomic number right here. Atomic number goes right here. Name goes here. Mass goes here. You're going to get that from your periodic table. Fill in the protons, neutrons, and electrons. Then what you're going to draw is a Bohr diagram, except because I did the circles small, you don't need to try and fit the number of protons and neutrons in the middle here. Maleva, since you put it right here, I'm not going to freak out. You notice how we were always putting like the 19p and the 12? You don't need to do that for these diagrams. Just show the electrons, okay? And then do the Lewis diagram. So let's do one together. Let's do lithium together. So first thing that goes above lithium is the atomic number. What's lithium's atomic number? 3. So all of you will put a little 3 there. The actual name goes here, lithium. What goes beneath lithium? Oh, the mass? What is it? 6.8? 6.9? Okay. How many protons? How many protons? 3. How many electrons? 3, because it's not an ion. How many neutrons? Take the 6.9, round it off to what? 7. Take away 3 is 4. What's the Bohr diagram going to look like? 2 electrons on the inner shell, 1 on the outer shell. And the Lewis diagram, all you care about is the outer shell. So Cassidy, how many electrons are in the outer shell of lithium? 1 dot, wherever you want to put it, on top or beside, I don't care. So that's those ones. They're going to get a little tougher because you're doing some more. You're going to do about, I think, 12 of these. Then, can you look at this page, please? Here we're doing ions. And there is a typo in my answer key. So if I was doing a lithium ion, it would be only 2 electrons in the outer shell because that single electron by itself has vanished. But I forgot to go like this. And lithium, is it, what's the charge on lithium? What does it say on your periodic table? Plus. And I forgot to go like this. Plus, but you'll notice no dots on the Lewis diagram because the outer shell for lithium has become empty. Okay? I'm going to let you kind of wrestle through this, kind of work through this. If you get stuck, you can also look at your textbook as well. You can ask a neighbor, you can ask me, but I want to give you the rest of class.